Hello, I'm Rupesh, and I've been experimenting with Oracle Tech for over 20 years. I'm pretty passionate about education, and more recently, since Oracle's introduced OCI and especially OCI Gen 2, things have gotten really interesting in my career. I've authored 5 Oracle certification books in my career, and I speak regularly at Oracle conferences. And in my current role as a systems integrator and cloud architect, I've had some experience recently working with infrastructure as code, and I'd like to share some of those experiences with you. It's my pleasure to co present the session with Uma, who will introduce herself as well.
Hi, my name is Uma Balasubramanian. I'm a principal software engineer in Oracle Cloud Infrastructure, and I work in Resource Manager.
Thanks, Uma. So the format that this presentation is going to take is we will co-present, and at any time, feel free to ask questions in the Q&A chat. An expert will be on standby ready to answer your questions. And if time allows, we'll also answer some questions live at the end of the session. So why are we having this conversation? This presentation purely aims to provide a justification, and it's not a difficult justification for embracing the idea of designing and deploying infrastructure programmatically rather than the traditional organic infrastructure deployments that we see in data centers on-prem all over the place. Over the course of many customer implementations, we've learned that the cloud proposition is an obvious choice. With the maturity of cloud vendors, especially OCI Gen 2, there's even more compelling reasons to move to the cloud. During a recent project, we moved an entire on-prem data center in a 24-hour period to OCI. And this session shares the approach and more specifically the tools that we can use to get the seemingly daunting task done in an optimal manner. So some of the challenges that we've traditionally had with infrastructure provisioning in your on-prem data center and even in the cloud is there's a general lack of version control. Usually as projects come along, new infrastructure is provisioned over time and over staff turnover. You lose track of the old equipment hiding in the corner of your data centers. Audits tend to be a nightmare. And more importantly, once some commodity server fails, there's usually no patterns to quickly redeploy, and it takes ages to reprovision or recover your failed system. With the cloud proposition and specifically with infrastructure as code, you get to start on a clean slate. So my recommendation and what we've observed is design your future state as if it's the dream state that you'd like your infrastructure data center to look like. So you'll set up your tenancy, you design your identity and access management, your network, your storage, your compute, your database systems. And it's not permanent, but you start on a solid foundation. You make sure your groups, users, authentication policies, tagging framework, especially, are in place, and your governance is something that takes care of itself. So once your design is done on paper, how do you move that from design to reality? So usually when you're learning, when you're starting out, or you have a really small environment, you can use the Cloud Console and you create each resource manually using a point and click method. Um, you applied some strict governance because you've done your design and you're preventing rogue resources, but this doesn't scale. I'm going to show you a quick demo on how to build infrastructure manually using the Cloud Console. So say you need to create a compute instance, you can connect to this console and go through the wizard, and I'll show you in a second. So I'm logged into the Cloud Console. I hit the Create Instance button. I provide a name for the instance. Make sure that I'm in the correct availability domain. I'm in the Montreal region, so there's only 180. I'm okay with the default operating system, but I want to change the shape. I don't want an E3 Flex. Rather, I want a VM standard 2.2 with 2 OCPUs. That's meeting my design requirement. I choose my shape. I go down the wizard a bit more, make sure that the correct network is chosen, the correct subnet that the instance is going to reside in is chosen. Uh, I need to provide an SSH public key so that once the instance is provisioned, I'm able to connect to my new machine. Let me go ahead and paste that prepared SSH public key that I've got in my clipboard. Okay, there you go. And go down, just make sure I'm happy with the rest of the settings and hit the create button. So while the instance is being provisioned, time is passing clearly, but I can review the instance information, make sure that I'm happy that I've made the correct choices. IP addresses get assigned as the instance gets provisioned. I can confirm all these details, and I'll go down and take a look at the progress of this provisioning. Okay, it's at 15%. Okay, there, we've done. So the important thing to note here is from the moment I started to the time it finished, it's taken just under 1 minute, which sounds amazing, except this doesn't scale if I've got 500 or 5,000 compute instances to work with. Moreover, because there was so much of pointing and clicking and sometimes needing to type in names of different artifacts, it's error prone because there's a human involved. So we know why we need to rethink this. It doesn't scale to use the console. So the recommendation for large scale design, deployment of large scale design onto cloud is to treat your infrastructure as code. And this gives us some benefits, right? You can version it, which is an interesting way to think about infrastructure. You can automate it because it's done programmatically. There's scripts, they can be scheduled to run when people are busy doing other work. It enables an agile approach and the use of DevOps technologies. It's efficient on time and money. So in the real world, in practice, we've seen these move and improve projects, but largely you have to identify what to take and what to retire. Often there's some system that is on a really incompatible piece of equipment that needs to be retired, and it's just hanging around, and sometimes people don't even know it's there. So this is an important exercise. And then start with a view of designing your future data center exactly like you wish your current data center was designed. So there's several options for codifying infrastructure. You can use the SDKs that are available. You can use Chef or Puppet or Packer or Vagrant. There's many DevOps tools available. In this presentation, we specifically speaking about Terraform. Essentially, the cloud vendors, and especially OCI, provide an open API-driven interface to working with resources, working with infrastructure. So treating infrastructure as code changes your deployment paradigm by supporting massive yet consistent infrastructure architectures to be programmatically deployed. So what is Terraform? So it's been around even before the age of cloud. It has matured as a DevOps technology to treat infrastructure as code. It's enabled for OCI through a piece of software called the OCI provider for Terraform, which basically exposes a list of resources that Terraform can reference when provisioning, updating, or destroying resources. Each OCI resource and their respective set of properties are set through config files, which can be text, HashiCorp config language, or HCL config files, which are, or they could also be standard JSON format. A Terraform state file, it's an interesting concept. It keeps track of the infrastructure that has been provisioned, and for as long as you consistently using Terraform to provision, update, and destroy resources, your Terraform state file remains consistent with and in sync with what's actually been deployed. So let's look at a quick example of a Terraform file. So it's fairly straightforward, quite easy to read. Notice that in this Terraform file, there's a resource called OCI Core Virtual Network. We're giving it a name VCN1. And it's got 4 properties, a CIDR block that we're specifying. There's a secondary resource being defined called OCI Core Instance with several properties set as well. So I'm going to show a quick demo of using Terraform to create a VCN. So I'm back in the OCI console, and notice in this compartment, I've got no VCNs. So I've gone to my Terraform server where I've got my configuration set up. In this directory, there's a state file and a Terraform file called vcn.tf. I'm going to look at my environment that I've set. Notice there's a few environment variables prefixed with tf var. Let's specifically look in this vcn.tf file. There's a tenancy OSID that references that environment variable OSID. So let's go ahead and try and run Terraform plan. So Terraform plan reads the Terraform files in that directory and generates an execution plan of what it's going to do. So notice there's an OCI virtual network resource that's going to be added. That's the plus sign that's next to it. It hasn't done anything yet. This is just the execution plan that's been generated from the files in this directory. So we now need to apply the plan if we want to actually create anything. So let's go ahead and run Terraform apply. We'll have to say yes to confirm. And in a few seconds, a new VCN's been created. So really efficient, really quick. There's a CIDR block that we specified in the Terraform file. So let's go back to the server and take a look at what's in there. So the Terraform state file, let's take a look at the contents. So in this file, it's basically in sync with what we've created, which is a single VCN named VCN1. We can see some metadata at the top of that. It's not so important. There's the properties for the state. Okay, so we'll do the last command, which is to destroy it. And basically, this just takes the contents of the Terraform file and confirms, do you really want to destroy it? We're going to go ahead and say yes. And once we take a look at the Cloud Console, we should see that it's been updated and there's no longer a VCN. So the important takeaway from this demo is you can do full lifecycle management of your resources entirely programmatically without even needing to interact with the console, just through API calls using Terraform and the OCI provider. So I'm going to hand off to Uma, who's going to talk about how to take Terraform to the next level and overcome some of the limitations specifically around versioning and sharing with other developers. Uma, over to you.
Thank you, Rupesh. My name is Uma Balasubramanian, and I'm a software engineer in Oracle Cloud Infrastructure. I'm going to talk about OCI's Resource Manager service. As you saw in the previous demo, there are a lot of manual steps in provisioning infrastructure with Terraform. Also, one of the biggest challenges in running Terraform locally is that when 2 or more teams update and run the same Terraform configuration at the same time, it might result in corrupted infrastructure state. Resource Manager solves this by locking your state file and allowing only one execution of a given Terraform configuration at any given point of time. Also, Resource Manager is a fully managed service and integrates easily with other OCA services. For example, you'll be able to specify granular permissions for each Terraform operations such as plan, apply, and destroy. Also, you'll be able to audit your infrastructure provisioning using OCI audit. This diagram shows the generic flow of infrastructure provisioning with Resource Manager. As a DevOps engineer, you will author Terraform configuration files and create a Resource Manager stack. The stack represents the Terraform files that codifies your infrastructure. A job is an execution of a stack and provisions the infrastructure, actual infrastructure, like the load balancer, instances, or the VCN. After the infrastructure is provisioned, the Terraform state file is generated, and which is a JSON representation of your provision infrastructure, as described by Rupesh in the previous slides. Now, let's see how to build your infrastructure using OCI Resource Manager Service. There are several ways to build your infrastructure. The quickest way is to use sample solutions. Sample solutions are predefined set of Terraform configurations that are used in common scenarios. Say you want to launch a compute instance, or you want to launch an autonomous database, or an e-commerce application. Sample solutions provide you an easy way to launch these infrastructure. Another option is to author your own Terraform configuration files by learning the Terraform syntax and going over the several examples given in our OCI GitHub repo. Once you have authored your configurations, you can onboard a resource manager via multiple ways. One of the way is to embed the deploy to Oracle Cloud button as shown in the screenshot on your repository page and allow your developers to directly launch stacks in Resource Manager. Resource Manager also integrates easily with other source code control systems and allows customers to get Terraform configurations directly from the external repositories, such as GitLab. Last but not the least, we have the traditional way of zipping up the Terraform configuration files and uploading to Resource Manager. Now let's see a quick demo of building your infrastructure from scratch using Resource Manager. So this is the OCI console, and this is my compartment where I'll be creating a stack, and these are all the different options for creating a stack. I'm picking sample solution, and as part of the sample solution, there are several pre-built configurations, Terraform configurations for you to readily deploy. And I would like to deploy a compute instance, and hence I'm selecting that solution. You can name the stack to whatever you want. And we can select the VCN in which this compute instance should reside, and the subnet, and also the other SSH parameters. Once you have created the stack, you can see that the stack is active and ready for operation of all these actions, Terraform actions. We are executing a plan job first, and at the end of plan job execution, you can see the execution plan that was generated that says 3 items to be added and 0 to be destroyed. And then we are executing an apply job that will actually provision the infrastructure. And at the end of the execution, you can see the instance that was created and provisioned. Now that the jobs are complete, we can go to the compute instance page and see whether your instance is there. As we can see, our test instance is like up and running. Now that we have seen how to create an entire infrastructure ground up, let's say you already have your infrastructure created and is currently manually managed. How could you move to Resource Manager service? Resource Manager provides a feature called Resource Discovery, which enables you to create a stack from existing compartment. By creating a stack, you'll be able to capture all the deployed resources in that compartment as Terraform configuration and state files. Once your stack is created, you'll be able to execute, plan, apply, and destroy jobs and leverage all the benefits of moving to Resource Manager service, such as versioning your infrastructure, tracking changes to your infrastructure, and also enabling easy collaboration across multiple teams. With the generated Terraform configuration files, you will also be able to replicate your infrastructure in another region or tenancy or compartment as shown in this diagram. Also, if you are new to Terraform, you can learn about Terraform's HCL syntax and how to represent Oracle Cloud Infrastructure resources in HCL as well. Now, let's see a quick demo of discovering an existing infrastructure with Resource Manager. This is my compartment where I have one instance running, and in the same compartment, I have 4 object storage buckets also available. Now I'm going to resource manager and I'm going to create a stack from this existing compartment. Here I'm selecting my compartment name, and also we can specify the services that you'd like to discover. You can choose to discover all the services or only few services. It's up to you. Here I'm selecting core and object storage. Core includes compute and block storage. Now the stack is getting created and it's in a state called creating, which means there is an asynchronous work request that is running, that is discovering these resources. Once this work request is complete, we can see that the Terraform configuration file is generated for us, and you will be able to download the Terraform configuration file and view that the Terraform TF state file contains the instances that were available in that particular compartment. This shows the core.tf Terraform file, which is, and also this shows the object storage.tf, which shows the object storage buckets that are discovered from my compartment. If you are a customer already familiar with Terraform and have existing state files that are managed by Terraform, you can now easily onboard to Resource Manager without destroying your current infrastructure. First, you need to create a stack with your Terraform configuration. Then you can use the import state feature in order to import your existing Terraform state file. Once you have done that, your infrastructure will now be managed by Resource Manager service, which enables state file locking and prevents corruption of Terraform state. Also, Resource Manager supports a very important feature called drift detection. Drift detection is best explained with an example. Let's say you already have an infrastructure provision with Resource Manager and it's up and running. Later, let's say you get a live site incident and your DevOps engineer determines the issue to be a bad host in your infrastructure. So in order to mitigate the issue, he or she removes the bad host out of rotation. That is, he performs a quick out of band fix. Now you have introduced something called a configuration drift. The real infrastructure is not the same from what is represented in the Terraform configuration files of the stack. Unknowing to this drift, if another DevOps engineer runs an apply job again, he would put back the bad host back in rotation. In order to avoid these scenarios, you can run drift detection prior to running your apply job to determine if if the provision resources have different states than those defined in the stack's last executed configuration. With drift detection feature, you can also view detailed drift status for each of the resource that are in your infrastructure. Now let's see a quick demo of drift detection. So this is my existing stack and I have already run drift detection on the stack. And as you can see, the drift status says it's in sync. So all the resources are in sync with what is there in the real infrastructure. Now I'm going to go to one of the compute instance and I'm going to rename the display name to something else. And if I run drift detection again in my stack, I should be able to view the drift. This creates an asynchronous work request that runs the drift detection report and generates the report for us. Once the work request is complete, we will be able to view the full report. As you can see, the instance is in modified state. Not just that, You can also see the actual property name that was changed. The display name has changed here in this case. That's the end of Resource Manager. Now I'm going to hand over to Rupesh, where he will talk about his experience with onboarding customers to Resource Manager. Off to you, Rupesh.
Thanks, Omar. That was great. So, um, Resource Manager is fantastic, and it actually really elevates using Terraform in the OCI context. It's a real differentiator. I came across this tool which is called OKAT, and thanks to, I guess, shout out to Andrew Hopkinson from Oracle's A team. It's a visual studio that actually allows us to design our OCI infrastructure as if you're an architect doing a regular design on paper. And from there, set some properties, configure some Terraform initialization, API signing keys, etc., and actually generate resource manager stacks, jobs, Terraform files to download, Ansible files as well. So really handy tool, which we've used to take customers to OCI and basically bring an architecture to life from design to deployment. So I'm going to quickly show a demo of the OKAT tool. So you start with a blank canvas, and I'm going to grab a VCN. It's a good place to start. And onto this VCN, I'm going to stick a public subnet and, well, I'll stick in two subnets, but I'm going to change the second one to a private subnet just now. I'm going to grab a few route tables, some security lists to attach to these subnets as well. And this is really great, and it's a very visual way to see how your infrastructure is put together. I'll need an internet gateway because some of my instances are going to need to talk to the internet. I click on the properties tab on the right hand side of this tool. I'm going to allocate route tables and security lists to my public subnet. I'm going to change my second subnet to private with the checkbox and allocate a route table and security list to that second subnet as well. So this tool lets me also add compartments, database as a service, autonomous database structures as well. So I've dragged an instance into this first subnet. I'm going to drag another compartment. I'm not going to put anything into that for now. And just take a closer look at the properties. Yeah, it's given it a name. It's just a compartment. That's the extent of its properties. I'm going to choose the validate button on the end of this, underneath the properties button, just to validate the infrastructure that I've drawn. So let's just take a look. There's some errors. So the database system needs a public key. So much like we provisioned manually an instance and specified an SSH key, we're going to need to do the same for any instances and database instances as well. So I've pasted in a public key. I'm validating. It's given a few warnings, which I'm going to ignore for now. So I head off to the menu. I go to Resource Manager, and I can actually generate an OKAT stack. I can give it a name and create it. So off it goes and creates a stack. And that was a really quick demo of how powerful a visual designer is, but how well it integrates with Resource Manager when needing to take your design all the way through to deployment using infrastructure as code. So that was the end of our presentation, but we're going to do some Q&A. I'm going to take a look in the chat and see if there's any questions that have come up. And I think this is for you, Uma, so I'll read it. Someone's asked, can I provision resources in a region other than the region where I created my stack?
Yes, of course. You can create your stack in one region and orchestrate resources in a different region also by declaring the region variable in the provider. If you have done it accordingly, it should definitely work. And the value of the region variable determines where your resources will be created.
Okay, excellent. I see another one. Can I provision, no, what is the version of Terraform provider that Resource Manager supports? And how do I handle upgrades to the version of the Terraform provider?
I see. Resource Manager uses the latest version of the OCI provider, OCI Terraform provider. Once a new version of the Terraform provider is released, you will have an option to upgrade. You can also specify this as a parameter in your Terraform configuration file. Let me check if you have anything. Yeah. Okay. Uh, there is one question. Does Terraform require all code to be placed in a single file?
I'll take that. No, all files in the demo that I showed, there was just one file, but all files in the current directory from where you're running Terraform are processed. And it's quite common to find a separate Terraform file for providers, as well as infrastructure like network, compute, block storage resources. Each one has a file, and then you neatly segregate your resources into each into their own Terraform files.
I see. Maybe, yeah. Let's check. Is there anything else that we can answer? Uh, what are the most common HCL elements used in Terraform config files?
Oh, that's a good question. So I almost always see the variable element used, and that's used for sending and receiving data values from the environment to and from OCI. There's also the resource constructs, which are the primary constructs. We've seen some examples of them today, and they typically consist of blocks of properties describing one or more infrastructure resource objects. And of course, the provider element that exposes the IaaS resource types to Terraform. In my earlier example, the OCI provider exposed the virtual cloud network resource type. And these resource constructs can then interact with this type by creating, managing, destroying elements of this resource type. I don't see any other questions in the chat, so thanks, Uma. Okay, so thanks everyone for your attention and attendance of the session.
Thank you very much, everyone.
Bye.
Bye.